If you drive to the outskirts of any major city, then turn and look back at downtown, you'll see the skyline. The skyline you're viewing, the silhouette, consists only of the buildings that are tallest from your perspective. There might be shorter buildings just in front of these skyscrapers, but they're excluded from participating in the skyline because they are being what we call dominated by the taller buildings behind them. But if you move much closer to the buildings, your perspective would change, and so would the members of that skyline. This is the concept behind a skyline query. In a skyline query, you're attempting to pull all the highest values or most optimal values for a given condition or filter. You may not have heard of a skyline query, but you've certainly experienced them as a user. Skyline queries can vary from the quite simple, show me the cheapest flights to LAX, to quite complex, show me the most undervalued homes in commute distance to my office in neighborhoods with the most optimal combination of walk scores, school districts, and good restaurants. When complexity creeps in, it's usually in the form of higher levels of dimensionality. The more complex your data becomes, the more difficult it is and computationally expensive it is to run a skyline query. Luckily, this is such a common problem that a number of solutions and algorithms are already commonplace. But the issue with those existing solutions, at least according to the authors of today's paper, is that they struggle either when data has high dimensionality or when it's partially incomplete. Real-world data is messy like that, so the authors of today's paper are proposing a new solution to skyline queries that takes that messiness into account.